All right, linear inequalities. So far, we've talked about linear equations, yes. The equations of lines, the slope of lines, how to graph lines, vertical lines, parallel lines, all this other stuff. Where up until now, our equations have either 1 or 0 solutions. And if they intersect or if they don't, if they're parallel. Now we'll look at equations that have more than one solution. Up to infinite solutions. Up until now, when we talked about infinite solutions, we talked about same lines, but no more in this section. We're now going to look at inequalities. Instead of the equal sign, we will now use inequality symbols. We're going to use a lot more. Now, this one is called less than. This one's called greater than. Less than or equal to. Greater than or equal to. Not equal to or equal to. Each one of those have their own meaning and their own solution sets. Okay, when I said solution sets. When we talk about solutions when it comes to inequalities, we can write the answers down inside these squiggly lines. That denotes that it's a set of numbers, a specific set of numbers. Or we could simply make it as an equation, and that'll define the. In other words, if I gave you this, what would be the possible numbers for this set? What is this thing? Okay, how do we know this is less than? Good point. Just because it is. Well, how do we read equations? Left or right? So this thing means nothing. Other than that, it's just an arrow. If I had these are what we call binary operators. You need two numbers for it to mean something. You need a number in front of it and a number behind it. Kind of like a times or division or add subtracting sign. Those are all binary operators. 3 is less than 5. It always points to the smaller number. Or, as some people remember it, think of an alligator or a lion always eats the bigger piece of meat. So because we read it left to right, would it be the same this way? Would we use the same symbol there? No, we'd use another symbol. What symbol would we use? Remember, it points to the smaller one. It means the same thing. 3 is less than 5 is the same thing as 5 is greater than 3. You have to be able to read it both ways. They're bidirectional. No Kit Kats today? What this one says is this: X can be any number greater than 5 or equal to 5. So it could be equal to 5 or greater than 5, ... going to infinity. So that's my solution set. It's an infinite number of numbers. How would we graph it? Remember, the X, because all we have here is the X-axis. The only number we have is 5, so we put 5. How do we represent it via graph? Well, we're going to learn that besides these symbols here, we can represent the same things using brackets, parentheses, equality, inequality. What this means, the parenthesis means you can get infinitely close to that number, but not touch that number. The bracket means you can go to it and use it. So like for this one, what this one says is X is 5 to infinity. I can start at 5 and use 5 because it's on the graph. And it goes all the way to infinity. Can you ever get to infinity? No, so that's why we use a parenthesis. In other words, you can't get to infinity, so we use a parenthesis. This one says we can start off, we can use 5. X is greater than equal to 5. 6 is greater than equal to 5. 7, blah, blah, blah. The way we would draw it is like this. If X is on your left-hand side, whatever the direction the arrow is pointing, that's the side of the number you're going to shade. If X is on the left, whatever the direction of the arrow is pointing, from that number, we shade that direction. That's what we have to go through first. We have to define all these, what they mean. Last week, I gave you this sheet, the inequality sheet. Did y'all get that? Here. Yeah. Distribute them amongst yourselves. What we're going to do here with this sheet, we're going to see how it behaves, and how do we write that. As you can see, there are 3 forms of solutions, how we can represent the solutions. Set notation. When we answer in set notations, our answers will be with the inequality numbers, symbols. The interval notation is with parentheses and brackets. And graphing, we'll be using solid dots and open dots. So on the legend up here, if it's an equal sign, it's greater than equal to, which means it could be in brackets, which means the graph will be a solid dot. Less than equal to, it'll be in brackets, solid dot. Strictly less than, it's in other words, you cannot equal that number. It's parentheses and it's an open dot. So let's begin. What this one says, this is an infinite closed. It's closed because at this end it's solid and it goes this way. Where does it go to? It goes to infinity. So what does this represent? What is this squiggly, the shaded region there? What does that represent? That represents all of the x's I can use. The way it's written in set notation, we look at our x's. X is greater than, since it's a solid dot, it's equal to A. We look where x is compared to the numbers. If it's to the right, it's greater. If it's to the left, it's less than. Oop, that's the x. And it goes to negative infinity. So how do we write this one? Where is x? X is less than, since it's solid, or equal to A. So that's how we represent the set notation. We look at the graph and see what's shaded, and that's the x. Is it to the right? If it's to the right, it's greater than. If it's to the left, it's less than. Now, for interval notation, we look at the interval notation always has to have a beginning, comma, and end. So in our number set, our beginning, it starts at A, and it goes all the way to infinity. Now, A, can we use A? Yes, because it's a solid dot. Since we can use A, it's a bracket. It's a bracket also, if you notice here in the equal sign, it's a solid line on the bottom. It's a solid line on the bottom. Infinity, can you ever get to it? No, so it's always a parenthesis. Infinity and negative infinity, always parentheses. So the interval notation for this one, look at the bounds. The smallest one is negative infinity, and the largest one is A. That's where the shaded region is. I can never use infinity. A is solid, so it's a bracket. Now the next two represent an infinite set of numbers, and it's closed. I mean, it's open. So the set notation, where is x? X is greater than, since it's to the right, it's greater than. Can it be equal to A? No, because it's open. So it cannot be equal to A. It's strictly greater than. So for the interval notation, let's look at the end bounds. We have A to infinity, A, comma, infinity. We can't use A, so it's a parenthesis. And we can never get to infinity, so that's a parenthesis as well. The fourth one, it goes to the left. These are all my x's. So the set notation, where's x with respect to A? X is less than A. It's to the left of it. So the bounds, I go from negative infinity all the way up to A. Infinity is always, that's an open circle, so I can't use it, so it's a parenthesis. So that's an example of an infinite domain. It goes from A and goes to infinity. The next four are finite sets, where x is between two numbers. So what this one says, X is to the right of A, to the left of B. So in other words, we're reading left to right. A is less than X or equal to X versus solid. And X is less than or equal to B. For the interval, look at the endpoints. We have A, comma, B. They're both solid, so they're both brackets. Now, the shaded regions between A and B again. Again, A is less than X, but it's solid, so it can be equal. And X is less than B, and it's open, so it can't get to it. So my interval starts at A, ends at B. A is a solid, so it's a bracket and a parenthesis. So if it's an open circle, it's a parenthesis. If it's a closed circle, it's a bracket. The next one. X is between A and B. A is less than X. And X is less than or equal to B. So my endpoints are A and B. Is it parenthesis or bracket on the first one? Parenthesis. And the second? Bracket, right. And the fourth one in that set, A is less than X is less than B. They're both open, so just you can't get to them. And both of these symbols are parentheses. So far, so good? These are going together. These next four are going opposite directions. It's bidirectional. Notice what this is saying, if I picked an answer, the answer could be in this set, or it could be in this set. So how do I write the first one? Using the set notation. Well, this looks a lot like this. So we use X is less than equal to A. So X is less than or equal to A. And this other side says that X is greater than equal to B. And I put the word or between it because X can be in either of those two places. If I had to pick one number, it can be either here or it can be here. The next one, it goes to the left of A, that's your X, and to the right of B. So there's my X. The left side, X is to the left of A, so X is less than or equal to A, or X is strictly greater than B. It cannot be equal. Let's see what those look like in interval notations. we have two possible answers. For the interval, remember, we look at the endpoints. We go from negative infinity to A. That's that one. And then we go B to positive infinity. Infinities always a parenthesis. That's a solid dot, so it's a bracket. That's a solid dot, so it's a bracket and a parenthesis. We put the union symbol between there. The union and the or mean the same thing. It's just that they're represented differently. The unions are used in interval notation, and the or is used in set notation. The next one, we're going from negative infinity to A, and it's a bracket since it's a solid dot, unioned with open circle, B to positive infinity. Next one, yeah, X is less than A. Can it be equal to A? No, because it's open. How about B? X is greater than B, because it's to the right. Can it be equal? Yes. So we have an or statement. So we're going from negative infinity to A, and then B to positive infinity. Infinities are always parentheses. A is open, so is that parenthesis or a bracket? Parenthesis. Oh, no, A. And then B is a bracket with a U between there. So from A, I go to the left. From B, I go to the right. So X is strictly less than A, or X is strictly greater than B. It goes from negative infinity to A, and they're both parentheses, unioned parentheses, because they're open. You're going to have to know how to convert from one to the other method of these. So if I give you a set notation, if I give you this set notation right here, to convert it to interval notation, the easiest thing to do is convert it to a graph first, and then from graph to the other one. A graph is a much easier one to interpret. Okay, how about a point? How would you put this one? What's that? Nope. Nope. You've seen these before. How would you, if I just asked you to put A on a number line, what would I put as an equation? X equals A. How would you do an interval notation? It's just that, nothing else. So the only things we have are brackets and parentheses. So which one tells us that we can use this point? So what's that going to look like?
A bracket.
Bracket, A bracket. That means it's the only thing you can use. What this one says now, it's everything except A. In other words, everything except A. So how would you put that? If you like writing, we can say X is less than A or X is greater than A. That's a lot of writing. Is there an easier way to write that? What this tells us is everything except A. Since that's equal, this one's going to be not equal. And you can do the same thing here. You go from negative infinity to A, union A to infinity. But it's much easier if you just put A in parentheses because you cannot use A. And the last one is all real numbers. It's from negative infinity to positive infinity. That's how we represent it in interval notation. In set notation, we use that. That's the R that stands for all real numbers. Right. So these are the symbols and how they what they mean. So let's look at these. Solving linear inequalities. Treat the inequality symbol like an equal sign. In other words, solve the equations the same way when moving things around. Example 1A. 3x minus 5 is less than 6 minus 2x. And B, 13 minus 7x is greater than equal to 10x minus 4. Solve and write in other two forms. So what form is it in now? What form is it in now? I don't know. Well, maybe the sheet we just went through might help you. What's that? Set notation. Why is this set notation? It's because it has inequalities, the pointy arrow things. Set notation, if you look at the very top of your sheet, we just went through, the set notation deals with these inequality symbols. If they're brackets, parentheses, that's interval. When solving these, treat it as if it was an equal sign. So we have x on both sides. Which one do we move? No. Smaller to the larger, not right to left. That's high school. Always move the smaller to the larger. Why? Because if you move this larger to the smaller, you'll have a negative coefficient. And then that changes the whole equation. So always move the smaller to the larger. So we have two x's. Which one's bigger?
3x.
Why? Because it's further to the right than the -2. Using the number line, whatever's to the left is less than whatever's to the right. So since 3's in the positive, 2's in the negative, we move them to -2. How? By adding 2 to both sides. Three plus 2 is 5. X minus 5 is less than 6. So now we have always move the x's first. Always move the x's first. Now we have x's on this side, so everything that's not an x, we move to the other side. We have negative 5x is less than 11. And then divide by 5. Even though the computer will take this as an answer, you have to know how to put it, how the rest of the world reads it. This is why is this an improper fraction? Well, no, it's an improper fraction. Why is it improper? Yeah, because the bottom number is smaller than the top. In other words, how many times can 5 go into 11? 2 times, with how many left over? So if it's an improper, we can put it in mixed number. But the computer will take this, or if you want to make it as a mixed number. This is improper. And this is a mixed number. But for right now, we'll leave it as an improper fraction. So that's the first one. Put it in the other two forms. What form is this already? It's a 33% chance. Is it set, interval, or graphing? It's set because it's a pointy thing in there. It's a set notation. So you have to put it in interval and graph it. So whenever you convert from one to another set form, always graph it. Oh, I forgot to say here. If you have X on the left-hand side, it's not mandatory, but if you do, and you're in set notation, if X on the left, the direction the arrow is pointing is the direction you'll shade. If X is pointing to the right, so from A, I shade to the right. So the direction of the arrow, XA, it'll point less than X, greater than X to A and B. So if you do it that way. So the only number we have is 11/5. Is it an open or closed graph? It's open because there's no equal sign. Which direction do I shade? Because it's pointing to the left, I shade to the left. So where is it going to? Negative infinity. I need to know this for my interval notation. My interval notation says that x will go from negative infinity to x to 11 over 5. But since everything's less than 11 over 5, all I got to do is write x is less than 11 over 5. If you have trouble with it, the point and it goes to the left, the point and it goes to the left, it should look like this. So this is in set notation, this is in graph, this is an interval. Do the same thing with the other one, B. So what do we move where? Try again. Always move the 7 x's first. Always move the x's first, because that's the important thing. So yeah, because this is smaller, so we add 7x to both sides. So we have 13 is greater than equal to 10 plus 7, 17x minus 4. Now that you have all the x's to one side, then get all the non-x's away from there. Get rid of the negative 4 by adding 4 to both sides. 13 plus 4 is 17 is greater than equal to 17 over x. And then divide both sides by 17. So we have 1 is greater than equal to x. If you would take your paper and just flip it over, then x would be on the left-hand side and 1 would be over here. It would have to still point to the x. You can rewrite it where x is on the left by just flipping the whole thing. So the graph, the only number we have is 1. Is it an open or closed circle? It's a closed circle because there's an equal underneath it. Which direction do I shade, left or right? It's pointing to the left, so I shade to the left. So x is everything to the left of 1, so x is less than or equal to 1. I'm sorry, no. It goes from negative infinity to positive 1. Put it in interval notation. Number 2, we'll worry about when we do the next chapter, because we haven't talked about radicals yet, or rationals. Yeah, this is section 6. Example 3. We have to move very slowly because this is the basics. This is the very, 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 very basics of math. you'll need to know all of this stuff to do chapters 4, 5, and 6. The better you know this, the easier those will be. Number 3. This is what we call a tripartite equation. Which means it has 3 parts. We have one number, an equation, and another number. So here's your number A, here's your function with X, and here's B. Whenever you have this, focus on the middle term. Whatever you do there, you do to the other 2 sides. So what are we solving for? What do we always solve for? Always solve for X. That's the only variable we have inside there. So how do we get the X by itself? What do we have to do first? Subtract what? Nope. How is this connected? Is there a plus sign between there? No. Is there a minus sign? No. Is there a multiplication? There's no division sign in there. Division has to be either that, or that. If there's nothing between there, that's multiplication. So this is multiplied. This is the only thing that's added to it. Now, whenever we solve something like this, remember we have the order of operations. We do the special ops first, the multiplication division, and then the addition subtraction. When we're asked to solve for something, when we're asked to simplify, we do that. When we're asked to solve, we do it backwards. Of course, we get rid of the parentheses first, the special operations, but then we get rid of addition, subtraction, and then we get rid of any multiplication division. All right, so here, since we're solving for X, get rid of pluses and minuses. So we get rid of the 5. We subtract 5 from all 3 terms. They're both negative. 5 plus 3 is 8. The 5s cancel. 7 minus 5 is 2. To get the X by itself, there's no plus, there's no minus, there's no division. So this is multiplication is the only operation that doesn't have to be there to be there. So this is read 2 times x. So we divide both sides by x. I mean by 2, the coefficient. 8 divided by 2 is 4. The 2's cancel. And 2 divided by 2 is 1. So what's that graph going to look like? We have a -4. We have a +1. X is between there. So is -4 an open or closed circle? And 1 closed. Okay, here's something also. Some systems, instead of open and closed circles, they may be using parentheses. So parentheses and brackets. That's what you have to put in there. If it's on the left-hand side, it's open parenthesis, bracket. If ours was like this, then this would be that bracket, that would be that parenthesis. So it has to be open on this side and closed on this side, whether it's a bracket or parenthesis. Example 4. Solve this equation. 2x minus 5 is less than equal to -7, or 2x minus 5 is greater than 1. It's got a word or in between there. If it has that, then we have to solve this thing, graph it, and see what part of the graph is shaded. So let's solve both of these separately. What do we do here first? What do you have to get rid of first? The 5, because you're solving for x. This is the only number you're looking at. We're solving for x. We have to get rid of anything plus or minus. So we add 5 to both sides here. Well, same thing here. Add 5. Two x is less than equal. 7 is bigger than 5. It's negative. 7 minus 5 is 2. 2x is greater than 5 plus 1 is 6. Now I do what? I divide by 2. So I'm going to get the x by itself. And the other equation, I divide by 2 also. It's -1. X is greater than 3. So these are my set notation answers. I have -1 and 3. Those are my only two numbers that I have. Is -1 open or closed? A solid or open? It's a solid dot because there's an equal sign. And 3 is open. X is less than -1. So it goes to negative infinity. And it's greater than 3. Now a word problem, an application problem. It says, for her interior decorating job, Natalia can be paid in one of two ways. Plan A is paid $250 plus $10 per hour. Plan B is just a flat out $20 per hour. Suppose that she takes a job for N hours. How many hours N would Plan B be better for Natalia? So the first thing we have to do is write what we have. We have Plan A says $250. The word plus is plus $10 per hour. Plan B says it's just $20 per hour. So we have to put them into math statements first. We know plus means plus. What does per hour represent? How do we represent per hour? Read the statement. What does it tell us? What is the hour? Should I start having the exams in the testing center? Because all of y'all are pretty much too complacent, not being able to do basic math here. I should have it for everybody. Well, it's going to be for everybody. What represents hours? N. So this one is 250 plus 10N. That equals A. B is equal to 20N. The question is asking, for what value N is Plan B better? So what number of hours is Plan B greater than Plan A? So now what do? What is the formula for B? 20N. And the formula for A? 250 plus 10N. Now we solve for N. So we subtract 10N from both sides. And divide by 10. So cancel zeros. So anything greater than 25 hours, Plan B is better.